So today we're going to be doing simple interest problems. So these are problems where accounts are going to be accruing linearly. Compare that to compounding interest problems where our accounts are going to be growing at an exponential rate. Here our accounts are going to be growing at a linear rate. So it's going to be simpler. So let's do this first equation. I equals to the PRT, where I equals to the interest fee for borrowing. So if you borrow money for 1 week, I is going to be the interest, the cost of borrowing money for that 1 week. P is going to be the principal. How much is the original amount for? R is going to be the interest rate, the annual interest rate that we're going to be interested in. And T equals time in years. Now typically when we are working with simple interest problem, we're going to be working with time periods that are less than a year. So if we have 3 months time periods, then that's going to be 3/12 of a year. So that'll equal our T, which will equal to 0.25. So 3 months is 0.25 of a year, so T will equal to 0.25. So let's calculate how much interest is going to be charged on a 9-month loan. Interest on a 9 months loan with an annual rate of 12% for $100. So you borrow $100 from your friend, you're going to pay your friend back 9 months from now with an annual interest rate of 12%. How much is it going to cost you to borrow that $100? So I equals to 100 times 0.12 times 9/12. Alright, so look at the 9/12. We can simplify this. That's 0.12 times 0.75. Plug that into our calculator, and we're going to get I equals to $9. So this is what we call the interest charge on the account for borrowing $100. So if the cost of borrowing $100 is $9. Alright, so let's think about a little bit more as A of T equals to P plus PRT. Well, you can think about A of T as being how much money is going to have to be paid in full at the end of the time period. And compare this with our original I equals PRT. All we can see that A of T equals to P plus PRT. So how much are we going to pay at a future time period? Well, we're going to pay our original principal plus the interest that it charges us to borrow the money. Alright. And then a lot of times we consider A of T, sometimes we call this the amount at time T, or we might call this the future value. The term that we're going to be using in this class a lot going forward. So we might be interested in, hey, what's a 4-month investment equal to when P equals to 800, R equals to 0.09, so annual interest rate of 9%, and we know that T is going to equal to 4 divided by 12, which equals 1/3. Alright, so we can now plug this information into our equation. We're going to have A equals to our original 800 plus PRT 800 times 0.09 times 0.3 repeating. Well, this just equals to 800 plus 24, or A equals to $824. So let's think about this, put it into a little bit of context. So if we borrow $800 at an annual interest rate of 9%, that accrues as simple interest for 4 months, Well, how much are we going to pay back at the end of 4 months? So we're going to pay back a total of $824. So that means that we paid back our original $800 plus $24. That will be the interest fee, how much we pay in order for the right to borrow that $100. Alright, so let's think about an account that earns interest at a simple rate. So we are going to think about it in terms of time periods greater than 1 year, just to illustrate a point of how these accounts grow in terms. So A of 2 years, well, that's just 1,000 plus 1,000 times 0.04 times 2, which equals $1,080. 5 equals to 1,000 plus 1,000 times 0.04 times 5, that equals to 1,200. A of 10, how much money will be in this account at the end of 10 years, given that it accrues interest at a simple rate? 0.04 times 10, well, that equals to 1,400. So if we had an account that accrued interest simply, at the end of 2 years you would have $1,080, at the end of 5 years $1,200, and at the end of 10 years you would have $1,400. So let's plot this over time. 2, 5, 10. 1,000, 1,400. And I'm going to bust out this ruler to prove a nice point. This account is going to accrue interest at a linear rate. So at time 2, we're going to have $1,080. At time 5, we're going to have $1,200. At times 10, we're going to have account $1,400. And then we can extend this time out for as long as we want, and we can figure out how much money is going to be in the account at the end of that time period by simply extrapolating from this linear line. So this means that our account is not going to grow exponentially. No, it's going to grow linear. That is one of the implications of simple interest. That it grows linear. Alright, so now we can start asking some more questions. So let's say we have a rate of 10%, time of 9 months, or we say that's 9 over 12, well, that would be 0.75 for us. And we will want to know, hey, at the end of 9 months, we know we want $5,000 in the account, and we are going to be interested in how much money would we have to invest at the beginning of the account to make sure that we have $5,000 at the end of the account, at the end of the time period, given that we're going to invest this money for 9 months at a simple interest rate of 10%. So we're going to use our equation, A equals to P plus PRT. Well, this could be also rewritten as A equals to P times 1 plus RT. This is the same thing. These two statements are equivalent. It's just sometimes it's a little bit easier to deal with this guy with this type of situation. So let's start plugging in some of our information. We're going to have 5,000 for our total amount at the end of our time period. P is what we're going to want to solve for, plus 0.10 times 0.75 for our T value. And now we're going to want to solve for P. So 5,000 equals to P. Let's solve for what's inside this parentheses. 1.075. We can now divide both sides by 1.075 divided by 1.075. And 5,000 divided by 1.075 equals to $4,651.16. So how much money are we going to invest today in order to make sure that we have $5,000 at the end of the time period, given that our accounts accrue interest at 10% annual rate, and we're going to invest for 9 months period of time? Well, we're going to want our original investment to be $4,651.16. All right, so let's talk about T-bills. U.S. T-bills. So T-bills is that we're going to be loaning the government some money, and we're going to be figuring out some useful aspects of loans to the government. So let's say you buy a 180-day $10,000 T-bill loan, and you bought it for $9,893.78. All right, and we want to know what interest rate did we earn. So when we said we bought a $10,000 T-bill, that means we're going to be paid back $10,000 at the end of 180 days. And if we bought it for $9,893.78, that is going to be our principal, what we bought it for. Now note, to make our math easier, we're going to assume a 360-day year, or sometimes what we call a banker's year. Banker's year. Makes our math a little bit easier. So we want to solve, hey, what interest rate are we earning on this account? So we are going to plug that into the A equals to P times 1 plus RT equation. So we have $10,000 equals to $9,893.78 times 1 plus R times 180 divided by 360, since we're using a banker's year. Now we want to solve for this R right here. Alright, so what I would do is that I would divide by this $9,893.78 to both sides of our equation. $9,893.78. And we are going to be left with 1.0107 equals to 1 plus R 180 divided by 360. Well, let's clean this up. What is 180 divided by 360? Well, that's just simply 0.5. Alright, now we can subtract 1 to both sides. We'll be left with 0.0107 equals to 0.5 times R. We can divide by 1/2 to both sides, or times by 2 if you want to say. So 0.0214 equals R. Or we can say R is roughly 2.14%. So that is the interest that we are earning. That is the rate that we are earning on this T-bill that we bought. Okay, so we can do some more trickery. So let's think about, hey, you bought a loan, and then you're going to sell that loan to somebody else, and we can figure out what is the rate of return for the somebody else. So let's say you sell a friend a car. Now, the car is worth $3,500. Your friend doesn't have $3,500 to pay you back, but they can pay you back in time. And since you're a nice person, you agree to a 270-day loan at 10%. So you make this agreement with your friend, is that you're going to give them a loan for $3,500. they're going to pay you back 270 days from now at an annual interest rate of 10%. Now, 60 days into the loan, you get fed up. You want to go buy a TV or something, and you want to sell this loan that you have to somebody else. So that way somebody else can collect on this loan that your friend is going to repay back. So you agree to sell it to a third party. For $3,550. So you held this note for 60 days, and then you're selling it to somebody else for $3,050. And now we can ask, hey, what was the rate of simple interest rate for our new person, for the new person, the third party? How do we go about solving this? Well, this is kind of like a two-step problem. First, we want to figure out how much that someone's going to pay back at the end of 270 days, given the original loan. So we want to figure out what our total amount should be. And we're going to get the original principal times 1 plus the interest rate times 270 divided by 360. And that's how we can solve for A and T. So A equals to 3,500 times 1.075, or A equals to $3,762.50. So the person who bought the car is going to pay back somebody $3,762.50 at the end of 270 days. Alright, so now we can figure out what is the interest rate for the third person. So for the new person, we know A, P, and T. So A is still going to be the $3,762.50 that we just calculated. The P, well, what the person paid for this one was the $3,550. This is what the new person paid. And then for the time period, it is going to be 270 minus 60, all divided by 60, or 21.36. So that will be the time period for a new person. So now we can just plug that back into the equation that we'd be using. So we are going to be plugging that into the A equals to P 1 plus RT equation, where we want to solve for that R. So we're going to have $3,762.50 equals to $3,550 times 1 plus R times 210 divided by 360. So what I would do is that I would first divide it by just 3,550 to both sides, and we're going to get 1.0598 equals to 1 plus R times 0.583 repeating, where 0.583 repeating is our 210 divided by 360. So we can subtract 1 to both sides. We'll get 0.0598 equals to R times 0.583 repeating. We can divide both sides by our 0.583 repeating, and we are going to be left with 0.10262. Well, that is going to be the interest rate. That is going to be the rate that our new person is earning. So the rate for the new person is 10.262%. So the new person is actually going to be earning a higher interest rate on this investment. Alright, so that is some problems working with simple interest rates.